It is officially past 11 Eastern, 8 a.m. Pacific. So good morning, good afternoon, good evening, everyone joining us from around the tinyML community here. So we're going to get started now with our talk. Really looking forward to the agenda that we have today. Not two, but three tinyML talks that are going to be really exciting, cover a broad range of topics. So without further ado, let's get started here. So my name is Davis Sawyer. I'm one of the co-founders of a tinyML company called DeepLight and the local chair for tinyML Montreal and also Toronto. We have a really burgeoning tinyML community here in Canada, so we're really excited to be able to share some local and also some speakers from abroad. Also, the community is joining us from Parker Zhang from Qualcomm and Kevin Favre of Toronto, LG Toronto. So really excited to be able to put this together for you today. Chat will be from Brian Plancher on tinyMLedu, widening access to tinyML education and resources. This is a really awesome topic and also related to our third talk and some demos, I think, from tinyML for STEM from Greg Gage of Backyard Brains. I will be using tinyML for neuroscience in K-12. So this is going to be super fun. Let's dive in here. And again, thank you everyone for joining us today. First of all, I'd like to thank our tinyML Talk strategic partners, Aeon Devices, ARM, DeepLight, Edge Impulse, Emza Visual Sense, Greenwaves Technologies, Gravity Inc., HotG, Imagimob, Clickatek, Latent AI, Maxim Integrated, Micro AI, NXP, Prophecy, Qualcomm, Kixo, Reality AI, Renaissance, Rixen, SAP, Seed, SensiML, ST Micro, Stream Analyze, SynSense, and Sentient. There are additional sponsorships available, so if you're interested and want to join the tinyML community, get in touch with Olga. You can see her email here below. A couple of really exciting things, actually. So we're already kind of mid-January. We do have the tinyML Summit 2022. This will be an in-person event at the same location it was in the past at the Hyatt Regency San Francisco Airport, March 28th to 30th. Registrations will open this month, so stay tuned for that. And this will be an in-person event, which is super exciting. And concurrently, there is the tinyML Research Symposium. This is an open event. This is really a great chance to get up to speed and share what's happening in the research community here. So that will also be held at end of March. And again, sponsorships are available here. So in parallel, there is the growing tinyML communities on Meetup. You can join the link here below. As I mentioned, this is our first virtual chat from the Toronto group. Always like everyone staying tuned for when we can do more of in-person events. But tinyML is a global organization, can join here for anyone who's new. And then there's also the LinkedIn community as well. So also there is the YouTube channel. So all the talks from today and the talks from the past all go to the tinyML YouTube channel. This is an awesome catalog and resource of all the different topics that have been spoken about. And you can find that here at the YouTube channel. And the next tinyML talk, it will be just around the corner, January 18th, with Ashutosh Pandey from Infineon Technologies. The topic will be exploring techniques to build efficient and robust tinyML deployments. So that will be same time as usual, 8 a.m. Pacific on the 18th. Ryan is a Ph.D. candidate studying robotics at Harvard University, working with Vijay Chinapareddy and Scott Kundrisma and co-chairs for tinyMLedu. His research is focused on developing and implementing open source algorithms for dynamic motion planning and control of robots by exploiting both the mathematical structure of algorithms and the design of computational platforms. As such, his research is at the intersection of robotics and computer architecture, embedded systems, numerical optimization, and machine learning. He also wants to improve the accessibility of STEM education. He enjoys teaching and designing new interdisciplinary project-based open access courses that lower the barrier to entry of cutting-edge topics like tinyML. He also enjoys spending his free time with his wife, daughter, puppy, and ski racing in the winters.
So hi, everyone. I'm Brian. And today I'm just going to talk to you a little bit about some of the work that we've done for tinyMLedu to widen access to education and resources. I promised Davis I would keep this pretty brief and tee up Greg and keep it moving. So I'm going to just stay at a pretty high level here, but please feel free to jump in with a bunch of questions. If there's something you want in the moment, feel free to interrupt, etc. We believe tinyML is a really great educational tool for lots of different kinds of learners, since it sits at the intersection of machine learning, embedded systems, and lots of really exciting applications. Based on the last talk, it also can allow you to get really, really deep and get really, really technical. But I also think it also allows you to touch at machine learning in different ways at different high levels. So you can imagine that there's an embedded systems course where you're going to include a last sort of module on machine learning, and you can do that through tinyML. You can imagine there's a machine learning course that you want to have a hands-on demonstration. You could do that through tinyML on an embedded system. You could think of an application course where you're doing learning for some purpose, and you could actually then use tinyML as sort of a lab experiment there. And I think this is particularly true because tinyML allows you to sort of explore the whole machine learning workflow. So if you wanted to do a whole tinyML course, I think it's actually really fun to think about starting from data collection, moving to designing and training a very simple model, and then deploying it and making some inferences on some sort of device, giving you a lot of flexibility to touch on lots of different things. And what really excites me about tinyML as an educational tool is that it encourages so much project-based learning. And there's already been a bunch of courses that we've helped support and that have been out there in the wild that have been doing this. And students have been coming up with really exciting, interesting, funky, different ways to use tinyML. And I know Greg has some really exciting examples for later. And I'll just mention something that he won't talk about later, which is that, we've had people looking at plants and looking at water to try to detect diseases. And we even had a student group that put an Arduino on top of a little hexapod robot and was trying to detect whether or not it was on flat ground or bumpy ground using the IMU. And so there's lots of different kinds of things you could do with tinyML, and I think it creates a lot of creative opportunities for exploration for students, which makes it really fun and exciting. And finally, I'll just note that tinyML is also allows you to explore sort of deployments at scale. I think it introduces some really interesting points about MLOps, and particularly sort of now you have this diverse ecosystem of hardware. How do you actually deploy to all these different kinds of hardware beyond just how do you collect data, collect a model, and think of deploying it onto one device? And I'll just plug that we've been putting out some edX courses on tinyML. There's a fourth course coming out soon, and it will be around this sort of MLOps topic. So moving, hopefully now in a minute and a half, I've convinced you that tinyML is really good for education. So what is tinyMLedu doing, and why do we think we need to widen access to educational resources? And really, there's sort of 2 points. The first point is, there are very few courses out there on tinyML, and excitingly, there's more and more demonstrations and walkthroughs and things that are starting to show up. But when we started this project, 2 years ago, there were basically none. Despite the fact that there are billions and billions of microcontrollers all over the world. And so we think this is a really unique opportunity, especially globally, to try to create and share some educational content that will allow people around the world to use the devices they already have to do really exciting things. And the other point I'll make is that hardware that is low cost is not no cost. And for many people, despite the fact that tinyML hardware is very affordable, it is still quite expensive in a lot of areas of the world. And so there is definitely an effort that we need to do if we want to democratize access to tinyML to actually get hardware resources out to people who may not be able to otherwise access them. And so to do that, we've structured tinyML EDU as a series of working groups, doing lots of different things. We're creating edX courses. We have a group that's thinking about, hey, there's a lot of educational content that's more at the college level. How do we bring that down to K-12? Greg's doing a lot of efforts about thinking about how do we put this into other STEM disciplines. We're trying to translate some of this stuff into other languages. And we're working particularly with the Ph.D. effort to think about how do we actually get tinyML education and resources into the developing world. And I also just put your idea here because I will just keep plugging that we are a very open organization. We want your help. We'd like to grow tinyML globally. And so if you have an idea for a working group, a project, a thing you think would be very helpful, please reach out to us. Please feel free to join our meetings. We're meeting every week to try to think about this. And all we're trying to do is get educational resources and hardware resources sort of out there. And so I thought I would just share a little bit about what we've accomplished this year and then sort of open it up for questions. So for example, our edX course has had over 60,000 students from basically the whole world, which has been super duper exciting. From our 4D group, we launched an initial academic network of 20 universities around the globe. And with those universities, we held a 5-day workshop introducing tinyML. We had a bunch of seminars before and after the workshop. We have lots of new seminars, workshops, and meetups sort of planned in the new year. Obviously, COVID depending exactly how we do that, but we're getting good at doing remote workshops and all of this kind of stuff. And also hardware is finally coming. We've been hit hard by the chip shortage, but we should in the next month or so, be getting, hopefully, fingers crossed, a bunch of tinyML kits and some WIO terminals and whatnot, and be able to distribute them to the universities in our network to get them some hardware resources to allow their students to start to get some hands-on learning. And we'll be growing the network and probably having a call for more members soon. So if you are an academic at a university that would like to be a part of this, also reach out to us and look ahead for that. We helped teach 2 open source courses taught in Portuguese in Brazil. So this was led by Marcelo Rovai, and he basically took a lot of our edX materials and had the materials in English, but adapted them and changed them, and then was teaching the course in Portuguese. And there's more international courses on the way. If you would like to teach this course, you want to translate some materials, let us know. Everything we're trying to do is open access. He's made his materials open access, so we're hoping to continue to grow all of this. We held an outreach workshop for high school and middle school students and teachers of the Navajo Nation. It was like a 0 to hero workshop. We started with no background. Those materials are up online. One of the members of Navajo Technical University actually used Edge Impulse to try to spot fake Native American jewelry and had a really cool little demo on that. And so we're working to do these outreach workshops as well. So again, if you have an idea or want to help lead something like that, let us know. And yeah, there's just so much more. We're really kind of working across the board with whoever wants to help do this to just spread exciting opportunities for tinyML. And so I'll just end by saying our website is tinyMLedu.org. You can find links to a bunch of MOOC courses that we've designed and Edge Impulse has designed on there. We have a lot of materials from all the courses that we've taught. And if you teach a course on tinyML, we ask that, if possible, you share your materials with us open source, because if you click on that Teach tinyML thing, you'll get links to all the GitHub repositories and whatnot for those materials. And then we have the working groups that are doing all these different exciting initiatives. And so please explore, please join us, please help us. We just are hoping to get tinyML out there and growing. And so that's all I got for a formal talk, and I'll open it up to questions.
Thanks, Brian. That was awesome. I appreciate you. I think we'll have to do a follow-up talk so we can go into more detail on all these topics, because there's so much in there. So I appreciate you, keeping that as concise as possible. So we do have some questions here for you. The first one here is, what is the most affordable board from your point of view to start learning tinyML? That's a really good question.
Ooh, that's a tricky one. So I think that what I would actually say is that I would look for if you have an application in mind that you're particularly excited about, I would look for what resources and demos exist that use that sort of sensor, and try to find a board that has that sensor integrated into it. Because I think connecting external sensors and integrating sensors with libraries and all that kind of stuff can be a little cumbersome at first. And so especially if you have less interest, for example, if you wanted to do keyword spotting, I think both like the WIO terminal and the Nano 33 have integrated microphones. So for example, that might make it a lot easier. And I know there are examples out there that do that. So I don't know if there's actually one answer. I think it's more of, what are you excited about? Cameras? Are you excited about temperature sensors? Are you excited about microphones? And sort of trying to find the board that supports that with a library that exists and works out of the box is probably the easiest way to get what you want. I know that's kind of a non-answer, but I think
that's great. That's why I'm saying we need to do a dedicated talk here. I'd say it's like you said, it's very use case driven and different if you're trying to learn and prototype versus production, of course. So there's a lot of options out there. You got to decide what's suitable for you. So and I think that's why we've been trying to really develop and grow all these sort of resources. I know there was another question about, are these courses suitable for students? And that is actually the hope. The edX courses kind of assume almost no background. In the first course, we actually do a little like intro to machine learning. We do some intro to embedded systems at a high level, and we sort of are trying to design it so that anybody can access these things. And I think as there are more and more materials made, hopefully there'll be more and more demos that go with it on the hardware. I think there's some like core cross-cutting themes that we're trying to teach that should be applicable across any sort of board, but then there is a little bit of like technical deep dive in there. I think what's nice though is there is more software tools being built, right? As Liang was saying, like all of the Qualcomm stuff will compile down to all of their sort of hardware. And I know like Edge Impulse, for example, is trying to build an interface that you can sort of deploy to any sort of hardware. They have a breadth of vendors there. And so I'm hoping that all these tools start to make this easier and you don't actually have to pick, you can just go. Yeah, yeah, that the question would be like answered for you. That's awesome. So the last question here, I mean, we might go a few minutes over time today, so I know, like feel free to keep bringing questions. But last one, maybe Brian, before we transition here. So this is a straightforward question: are there already courses suitable for students to learn tinyML?
Yes. So if you go to tinymledu.org and you click on that courses thing, it might actually be just /courses. I have to double check how I did the pathing exactly. But there's the MOOCs from edX that we made. There's also Coursera courses from Edge Impulse, and we link them all off of there, and they're a great place to get started.
Cool.
And they're free.
That's the best. That's the best part. And I think a lot of these communities are just like it's growing so quickly. So having these kind of resources, education resources, boards, that's gonna be fantastic. So thank you, Brian, very much for your talk today, and thank you to all the strategic partners. And again, there's also additional sponsorships available. First of all, so the executive strategic partners of tinyML, you have ARM, the software and hardware foundation for tinyML, Edge Impulse, the leading EdgeML platform. Qualcomm AI research, advancing AI research to make more efficient AI ubiquitous. Sentient neural decision processors, end-to-end deep learning solutions for tinyML and Edge AI. And to the Platinum strategic partners, DeepLight uses AI to make other AI faster, smaller, more power efficient, from software to runtimes. Clicatech global IoT solutions. Reality AI add advanced sensing to your product with Edge AI tinyML. Renaissance, broad and scalable edge computing portfolio. And to the gold strategic partners, Maxim Integrated, enabling edge intelligence. Latent AI, adaptive AI for the intelligent edge. Also Micro AI, NXP Semiconductors. Seed Studio, the IoT hardware enabler. SenseML, builds smart IoT sensor devices from data. ST Micro, life augmented. SynSense, builds sensing and inference hardware for ultra low power embedded mobile and edge devices. And to the silver strategic partners, Aeon Devices, Emza Visual Sense, Greenwaves Technologies, Gravity Inc., Hotg, Imagimob, Kixo, Prophecy, Recent Technology, SAP, and Stream Analyze. So the next talk, again, right around the corner on the 18th, 8 a.m. Pacific, 11 Eastern, we have Ashutosh Pandey from Infineon Technologies, talking about robust tinyML deployments. And with that, I'd like to thank everyone for making this a really fun, really successful first talk from tinyML Toronto. Keep in touch for more groups, getting involved in the community, joining the meetup groups, YouTube. Everything's available online. Thanks again to the speakers, and wishing everyone a great day.